27 says, let f be a differentiable function defined on the closed interval from a to b, and let c be a point on the open interval a to b such that, and then we have three conditions. The first condition says that the derivative of f at x equals c is 0, meaning you have a horizontal line that's tangent to the graph of f at x equals c. The second condition says that the derivative of f is greater than 0, meaning it's positive between a and c. And then finally, the third condition says that the derivative of f is less than 0, meaning it's negative between c and b. Which of the following statements must be true? To answer this question, we need to analyze all three of the conditions that are given. The first one says that the derivative of f at c is 0. So before we go any further, what we need to do is be able to visualize what's happening with the graph of f. So first, I'm going to draw a number line to represent not necessarily the x-axis, but different values that x will take on here. So we're only interested in this interval between a and b, and we know there's some point c that's in between. The first condition says that the slope or the derivative of f at c is 0. So we don't really know exactly what's happening with this graph yet, but we know there's a point where x is equal to c where the tangent line is horizontal because the derivative is 0. This typically happens at a local maximum or local minimum, but it may also happen on a point where we have something like this happening. So let's look at the second two conditions and see if we can't narrow down exactly what's happening at c. The second condition says that the derivative of f is positive between a and c. So that means the slope of the graph of f must be positive. So the slope is positive, meaning that f must be increasing from a to c. Then it also says that the derivative of f is negative between c and b, meaning that f must be decreasing from c to b. Whenever f or any function changes from increasing to decreasing, that indicates that we have a local maximum at that point where the sign changes. So from a to c, the derivative is positive. At c, the derivative equals 0. And then finally, from c to b, the derivative is negative. Let's look through each of the answer choices to see if we can determine which one is true. Part A says f of c is 0. Without any further information, we cannot determine the value of the function. So A is not going to be true necessarily. It might be true. It might be that the x-axis is actually right here, but we don't have any information to justify that. Choice B says that the second derivative of f at c is 0, but we see that at 0, the function is concave down, which indicates that the second derivative is negative. So it can't be B. If the second derivative was positive, the graph would be concave up, but in this case, the graph is concave down. Letter C says f of c is an absolute maximum value of f on the interval a to b. This must be true because function f is increasing between a and c, decreasing between c and b. So even if we include the endpoints, f of c must be the highest point on the entire graph. Just to look at the other two answer choices to make sure that those are not correct, D says that f of c is an absolute minimum value of f, which you can plainly see cannot be true. And finally, E says the graph of f has a point of inflection at x equals c. A point of inflection is where the concavity changes, and we can see that the concavity definitely does not change at c. So the correct answer to 27 is C.